All right, we're going to be doing number 7 from the exercises for 13.10 out of the book. All right, we got to maximize 2x plus 2xy plus y um, given the constraint function 2x plus y equals 100. First thing I'm going to do is I'm going to rewrite the constraint function as a function of g. All right, equals 2x plus y equals 100. All right, now I want to write my gradient vectors. Gradient of f is going to be 2 plus 2, not y, 2y, sorry. Uh, Undo. Right. F of xy is going to be 2 plus 2y, yeah, 2y, I plus 2x plus 1j. And our gradient of our g function, right a little smaller here, it's going to be, we're looking right here, 2I plus j, the partial with respect to y. Next, we're going to set our gradient functions equal to each other. So we're going to have 2 plus 2y is equal to 2 lambda, and as I should have specified before, highlight this and bring it down. What we're doing is the Lagrange theorem. Gradient of f is equal to the gradient of g times lambda to find the critical points, or the so page, and we're going to set the y value equal to each other, the j value, sorry, which is going to be 2x plus 1 is equal to 1 lambda, right? Alright, so now I'm going to solve these for values of x and y. So let's see if we can bring 1 over, bring the lambda with it. We'll write it down like that. Alright, we're going to subtract 2 over. We're going to get 2y equals 2 lambda minus 2. Y, this is fairly easy, equals lambda minus 1. And right over here, we're going to get 2x equals lambda minus 1. And if you notice, we just found that over here. So we're going to actually substitute lambda minus 1 for y. So, oops, got to get out of the magic marker there. Erase magic marker? No, we'll just wait for it to go away. 2 x equals y. Alright. Now that will bring us back to our constraint function. If we have up here, I'll rewrite it down there. 2x plus y equals 100. 2x plus y equals 100. Now, wherever we see a y, we can substitute a 2x. So I'm going to do that right here. Bring this down here. We're going to get 2x plus 2x equals 100, or 4x, which is going to get us x equals 25. Now, if we plug this value back into our constraint function, we'll get the y-coordinate, it's red. So 2 times 25 plus y equals 100. 2 times 25 is 50. We subtract both sides by 50. We get y equals 50. Alright, and so this is a critical point, 25 comma 50. Now, we're supposed to maximize it, and since there are no other critical points that we see, we could assume that it's a maximum, but we have a way to test it. We can test the points near it to determine whether it's a max or a min. So we can plug in something easy. We'll plug in 20 for x, so x equals 20. And we'll get y equals, what's our function? 2x plus y. I'm looking right here. 2 times 20 is 40. 100 minus 40 is 60, so y will be 60. All right, and we'll plug in, we'll go same amount in the other direction, 30. And we'll get, let's see, 30 times 2 is 60. Then we'll get 40 for our y value. Now we plug in these points, and we will see. All right, so we got to plug these all into this function up here. So let's bring it down so that can I move it? Hey, look at that. All right. Scroll down. Of course, I could have just rewrote it. Because we're all plugging these into the function that we're trying to maximize. We're making sure that this point is indeed a maximum. So we'll plug in the point we got initially. And that's this one right here. So 2 times 25 plus 2 times 25 times 50 plus 50. All right, so we'll get 50 equals 50 plus 50 times 50 is 2,500. 50 times 50 plus 50 equals 2,600. All right, so if this is a maximum, then the 2 points that are near it on the constraint function will turn out to be less than this point. So we're going to do these two now, and that's how we can prove that it's a maximum. So we'll try point 20. So 2 times 20 plus 2 times 20 times 60 plus 60. Another fairly easy one. This is all basic math at this point. Let's see. 2,400 plus 60. All right. Now you see we did get it less, so that is starting to indicate that this is a maximum that we found, which is what the problem's asking for. And our next one, we're plugging in 30. 2 times 30 plus 2 times 30 times 40 plus 40. 60 plus 60 times 40, 2,400 again, plus 40, which is exactly what we got before, kind of like a hyperbola. All right, and so now we can verify that this value is higher up than the other two values that are near it, and it is indeed a maximum. All right, so therefore, we won't write the function right now. There is a relative max of 2,600 at point, what was our point? 25, 50. There we go.